you that if you've got your tablet or your smartphone or whatever device that you want to be using, since we do have wireless access, if you just kind of want to follow along and kind of dig into the tool as we talk about it as well too, go ahead and do that. And then when we want to have a few questions, we can actually kind of interact with it as well too. So this is the Climate Explorer. This is a subset of the U.S. Climate Resilience Toolkit. We developed this with NOAA in response to the President's Climate Action Plan. And so this was a national application that went from kind of concept to full delivery in a 6-month period. So talk a little bit about the philosophy behind that and then be able to interact with it as well too. Let me see if I can get this to look through.
Looks that way.
Should we just do the buttons?
Well, I'm trying to get the buttons going. It's not working.
Buttons aren't working either.
Gotta love modern technology, right?
Well, imagine if you will. So while we're doing that, let me give you the address for those of you that have your devices with you. It's Toolkit.
It's up there.
Oh, great. So toolkit.climate.gov. And when we look at the philosophy of how we put this together, is a lot of times what you might be expecting from the federal government is kind of a top-down approach. You know, don't worry, we know what we're doing. Here's tons of data, have fun with it. Instead, the Climate Resilience Toolkit was designed on a bottom-up approach and say, no, let's actually start with people like you and I and say, what are the things you care about? And these are either people or assets that we're responsible about looking after. So especially for us here at the NCGIS Users Conference, that's a lot of what our daily job is, right? Creating mapping applications for municipalities, for companies that actually connect data to things you care about. Well, the second part that we were really looking to do was to say, okay, well, what is this whole thing about climate resilience? And is there a process that we can go through and step by step look at how a community or a group can actually build resilience? So you see the website starts off with these getting started steps. It's actually front banner. And working with NOAA, we said, okay, let's do this bottom-up approach. And if you're a community, what are the steps that you would work through about building resilience? Well, most communities are not textbook learners, right? So the best way we learn is from one another, right? We're here at NCGIS to learn from one another. So the second part of the website is a series of videos that are showing how people like you and I, fellow Americans, are building resilience. And these are actually the taking action case studies that are in there that you can go in and search. And whether you're a restaurant owner in New Jersey, whether you're the city of Charleston looking at dealing with sea level rise issues, whether you're a farmer in Alabama, or even a surfer in California, what are the issues that you're interested in? What are the tools that you can link into to actually understand how to build resilience? Well, with all that in mind then, how do you actually provide GIS services to support that sort of vision? And so that's where we, in addition to the website, put together Climate Explorer. We'd like to talk to you about that today. So you can actually go into the top navigation pane and under Tools, or even from the website, you can go into Launch Climate Explorer. So if you're actually on the home page, it's on the bottom left of the home page. It's got a link in the Climate Explorer. It will take you to this page. And for those people that are not used to using a web browser for interacting with GIS information, there is a whole set of tutorials of, okay, do this, here's what your screen ought to look like, here's what this button ought to be doing, and so a whole set of tutorials that are there. But for this audience, you guys are pretty used to using interactive web browsers through the web. You can just go directly on and hit Launch Climate Explorer. Okay, Climate Explorer is open source. It was designed open source so that not only the map viewer, but the rest of the tools that support it are open source libraries. That if you like one of these widgets, that you can take that widget and put it into your application as well too. Why is it designed that way? Well, guess who paid for the development of this tool? We did, taxpayers, right? So since this is being paid through taxpayer dollars, took the idea that as we develop the application, it ought to be useful that way. The application is laid out with two main parts of functionality. You can see on the side banner here that we're looking at the layers view. And so with a typical map viewer viewpoint, you'd be expecting to see the layers that you could have a chance to turn on and off. However, notice that this tool is set up so that it actually fits under different topics. You can see on the top of the layer screen here that the topic of coastal flood risk is chosen. And then you've got two main categories of data. So remember I said we designed this so that it's bottom up. There are two main categories of data. There are the people and assets impacted. Those are the things we care about, right? Those are the things that are going to be impacted by these different stressors. You can see the other category are the climate stressors. So again, for a coastal theme, what do you think some of the main stressors are going to be? Well, sea level rise. And so you have the opportunity to be choosing layers out of each of those two to be able to overlay and see this cause and effect relationship sitting in there. You can see that on this screen that I've changed topics now. That instead of a coastal topic, we're looking at food resilience. So what's happened is we've changed your choices for the main layers that you'd be looking at. You're now looking at drought as one of the main climate stressors, and you're looking at things like cropland that are here. So you can pull up cropland and see where all the nation's crops are being raised and pull that up as a base layer. You can see the functionality in the map viewer has the typical buttons you'd expect. Zoom in, zoom out over through here. Also down on the bottom, the ability to change from a street view to an imagery view as well too. I've turned on cropland here, and I've turned on drought as well too, but what's going on, I'm really only seeing cropland, right, because it's been turned on top of drought. So I'd really like to be able to change the ability to look at a variety of transparencies, which we've got then the transparency slider. So the transparency slider allows you to change how much of the cropland layer we're seeing, and now you're seeing a drought layer showing through here as well too. We rely on web services, and so you can pull on in the current drought monitor, or you can pull up different historical drought monitors for looking at droughts of record and things like that as well too. But you can see then as a user, we've gone ahead and got a scene that we like, right? And this is a map that we think tells the story the right way. Well, say, okay, well, where's the data coming from? We've got an information button here that not only shows you the color code, but since we're pulling in web services from federal servers, we're also showing where you can go out and get that exact same service. You can click on the link sitting through here, go get that service yourself, pull it into your own application. It also gives you all the metadata that's associated with that layer as well too. Oops. That's interesting. Okay, well, let me show you one other thing here. We also have the ability to generate a permalink. So this little chain icon up here allows you to capture a URL. So exactly how you're seeing this map with the zoom, with the map layers turned on, with the amount of transparency, you can capture that URL, paste it into an email, send it to whoever you're working with. They pull it up in their browser, they see it exactly the way you're seeing it. And therefore you can then have like a phone conversation with them, or if you wanted to historically capture exactly that view for a report of yours, then you can capture that URL, something in the future, and pull that exact view that you've got and be able to interact with it as well too. So the second part of this functionality goes beyond the spatial view, right? When we look at map layers, we're looking at making decisions spatially. But with climate, we also want to be able to make those decisions temporally as well too. So you can go in the second part, which looks at historical data, and start pulling up an interactive graphing application called Multigraph that is linked to all of these climate reference networks all the way across the nation. And you can pull up the historical information on temperature and precip. Well, you can see that on the top view, and this is just from an area in Oklahoma, that these are annual views, and you can see, as you would expect, temperature to be colder in the winter, warming up in the summer. And you can see the background, what is normal, in the green bar. You can then see where the daily temperature readings start going outside your normal range and be able to interact with that. Same thing with precipitation. Precipitation has a red line that is showing what is a normal annual precipitation. It then has a colored in pink area that is showing precipitation to date for the year. Has this been a dry or wet series of years for Oklahoma? Dry, right. Yeah, you can see, year after year, we're underperforming about what is normal for Oklahoma. So they're in a large drought sitting through here. Okay, well, I showed you that to be able to show you this. Okay, the Climate Explorer is meant to be used to, again, do this bottom-up approach, right? We can present a lot of this information, but so what? If you can't put it into context, why would I want to be pulling up a set of map layers, or why would I want to be interacting with these graphs a certain way? So we have a whole series of taking action case studies. At each page on one of these case studies, and this is about a restaurant owner in New Jersey rebuilding his restaurant after Hurricane Sandy. What height should he be building base level of his restaurant so that he doesn't have to replace that restaurant when the next Sandy comes in? And how likely is it that he's going to be experiencing another Sandy? Well, you can see then, to make that decision, he has to work through these different steps of building resilience. And this is one case study that has actually worked through all 5 steps. And so you can actually see that he is in step 5, taking action. He's gone through the whole analysis, but he's done more than that, right? He's actually invested and put the filings in and rebuilt his restaurant at a certain level based on that analysis. Well, how did he do that? What data sets did he access? At the bottom of this exact same page, we pull up Climate Explorer and turn on the data layers that he looked at, zoom into the area, and his restaurant's outside of Tuckerton, New Jersey. We have captured the permalink for exactly that. So if you wanted to look at the data exactly zoomed in the way that he was seeing it, then you can just basically either click on that map, pull up the permalink, and it will instantly not only pull you up to that map with those layers, but it will also pull up then the precipitation curves for two of these climate reference networks close to here. And you can start to appreciate, like him, is, well, what was the problem? You know, was Sandy related to a lot of precipitation? No, flooding in Sandy was not. You can actually see that Sandy is the area that's highlighted sitting through here, that actually the hurricane the previous year, and I think it was Hurricane Irene, actually produced a lot more rainfall during that 24-hour period, but did not cause the flooding, right? It's a storm surge problem. And to appreciate that that was the climate stressor and not the amount of precipitation is what's shown in this case study. So it's really like a story map, right? There is the narrative about how those data layers come together and how you and I can learn from this restaurant owner about if we're looking to build resilience along the coast, what would be the things that I'd be asking? How could I actually learn from this case study? Well, you can see that this is another case study. This is also a coastal community. This is the area around Miami, Florida, that they've been doing a lot with these communities working together to be looking at this issue. But you can see that they have not got nearly as far along on the steps to building resilience. That's not a bad thing, right? This is not easy things to do. But they have done a lot to be looking at identifying the problem, their exposure, to actually determining their vulnerabilities and where they need to be spending their money to be building this resilience. Well, again, at the bottom of the page, we can actually see then how the city of Miami is looking at this. Now, all of the data layers that are coming into here are map services. These are services that are robust, coming from the federal government, that you can tie into your applications just like we pulled into Climate Explorer. We're actually pulling in these set of services from, and what's your new name now?
Our office.
Your office, yeah. Office for Coastal Management, Charleston. They just recently changed their name. And you can see then that we're looking at the same sea level rise threshold the city of Miami is, and that's 3 feet. Well, you can see by turning on 3 feet of sea level rise that it's just not South Beach and those hotels along the beach that you would be expecting to have to be seeing building resilience. Look where the blue is going. The land is so flat and it's connected by canals. That's the Everglades. And the main vulnerability for Miami is not the buildings that are coming up. They can do things to be providing resilience. It's fresh water. Sea level rise, if it gets this high, basically forces out the freshwater aquifer they have, and no longer will 4 or 5 million people have access to fresh drinking water. So the bigger vulnerability that they have is really looking at how do we handle this issue for saltwater intrusion. You can see the data layers that they looked at to be determining those sort of pieces. Okay, now I'm sure why everybody showed up is to be able to see the software architecture about how this is working. So for the next 20 minutes, we're going to talk about software. Let's just talk about how this is built, right? We've Toolkit is open source, and so on the data tier sitting through here, we have 2 different types of data coming into this. There are GIS layers that are coming in as these WMS and REST services coming in to this sitting through here, but we do have these the historical data records that are coming in to support each of the climate stations sitting through there. Is anybody following along? Has anybody tried to pull up the historical data? Did you pinch or stretch on any of those curves? So this is an interactive graphing application. that if you don't like the zoom that you're seeing, you don't want to see just 2 years, you can pinch and start seeing 20 years. Or you can go out and zoom in to see day by day. You know, if you want to change the vertical scale. So this is a purely interactive graphing application. So what we're doing is we're pulling in the base data layer from NOAA and providing it in a format that every night it gets updated for what their feed is, and so that it will feed into multigraph as well too. Well, as I said, it took us basically 6 months from concept to delivery on this. Well, how was that possible? Well, there were a lot of tools that other federal agencies and partners had already paid for. Some of them in the audience, the U.S. Forest Service. So Bill Hargrove is going to be giving a talk tomorrow on Forewarn. But a lot of the basic building blocks of the open source map viewer and multigraph were engineered and tested for a different application. They were basically repurposed to be able to serve this as well too. So the importance about this open source approach is you build these interacting modules, the things in yellow, and they're packaged in applications. And so you're seeing Climate Explorer in the red box as the application that you're working through with your web browser. But it's pulling in these different modules in these containers and being able to be built up that way. And so it really is the beauty of open source and creating modules is you can pick some of these pieces up, repurpose them to be able to quickly put out another application. It's also really the importance of a lot of us going to these map services instead of each having to worry about creating a GIS layer, serving it ourselves. If we can take full advantage of those map services, then we get a much easier ability to quickly ramp up this type of application. So where does the data come from? Talked about these overlays or WMS or REST services. That's coming from a variety of different locations. Again, as if you click the information icon, you can actually go right to the same site where the service is coming from. The historical data is coming from the Global Historical Climatology Network that NOAA supports through the National Climatic Data Center. There's thousands of stations sitting through there, and we are comparing it against the most recent climate normals as well too. So those background normal layers that we're seeing are the most recent normals that we're experiencing today. And precipitation is this derived yearly cumulative sitting through there. They are coming in from a data conversion, so a CSV file, and we've got one of those modules that is basically taking those, cataloging every night, going in and adding to that file as well too. So it's a constant updated service. So I just really like to finish by the philosophy that we approached is, with really these decision support tools, you first really have to start with really data from trusted sources of information. As soon as you start presenting information that's either not accurate or current, you've lost the customer. And that's certainly not something you want to do in a topic that is in so much controversy or discussion as climate change is. Visualizations really help make that data really relevant, and through the storytelling, people can understand the application of that data. It takes it out of its mystery of science and turns it into the reality of, oh, here's somebody like me that I can really look at that's using this data for this specific purpose. That the storytelling is really that critical piece to get that science into the hands of the decision makers, because a lot of this data is dealing with uncertainty. And it's only through a little bit of a narrative can you understand what that uncertainty is. Also, group decision making, which we enter into with communities all the time, is really this iterative process that if you can build the tools like with these permalinks, you can give the ability to come back and keep building on that understanding. And really, it's really what our whole conference is about this week, about this collaboration, that we all know that these are too big a task for really any of us to be able to do by ourselves. It's really this cooperation between government, academia, and industry working together to do these things. Also to be able to create these in modules that we can reuse and keep building on that efficiency as well too. So with that, I'll finish and open up for questions. Yeah.
You indicated that you've been watching DC. How much do you feel that they are actually believe this is even true? That if you're climate change, global warming, it's not which obviously global warming has nothing to do with climate change and two different things. How do you feel that government is?
Yeah, so the question is how do we think government, different decision makers are actually accepting this? I think those that are open to accepting it or being forced to accept it, what you find is a lot of communities have the best ability to be building resilience actually after they've been hit by a major event. So New Jersey post-Sandy